Right, we're carrying on with this magnetism. So before we carry on with the questions, we need to go, what is a uniform magnetic field? Right, how do we know that? We know a magnetic field is uniform when the lines are straight, they're parallel, and they're equal distance apart. Right, a magnetic field runs from north to south. This one, when you have a wire cutting across a magnetic field, or a magnetic field cutting across a wire, whichever way you want, it induces a voltage. You end up with an induced voltage, and then that can allow current to flow. And then you've got Fleming's left-hand motor rule, or Fleming's left-hand rule. We said, remember, father, mother, child. Father is the thumb, and the F stands for force. It tells you that it's the force going up. And then at right angles to that is your first finger. Yeah, that's your mother. That's the magnetic field, the direction of magnetic field. And your third finger is your child, which tells you the direction of current flow. Right, let's move on. Let's go. We're here now. Complete the diagram by labeling the poles on the bar magnet. Remember we said the magnetic field goes from north to south, and look, it's going in that direction. So this must be north and this must be south. Oh, right, let's carry on. North to south, that's fine. Describe an experiment to investigate the shape. Okay, it doesn't have to be direction, but let's put it in. Right. The one that I tend to do is this one. I say place a card over the bar magnet, sprinkle on some iron filings, tap the card to reveal the shape. Right, we can add this, but we don't need the direction, so we can use and it's called a plotting compass. At the end of the magnet to show the direction of magnetic field. Right, let's try question 5. A student investigates how to produce voltage. He hangs a magnet from a spring onto a data logger. So what's happening is this magnet's going to go down and then back up and down and back up. The coil is stationary and it's linked to a data logger. Now if you notice here, this is high and it's getting lower and lower and lower, right? The reason that is because, you know, whenever you release a spring, it goes boing, 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 and there comes a rest, doesn't it? Excuse the sound effects. Because there's inefficiencies, whether it's friction or whatever it is. That's why this amplitude, so let's get this right. Here's a wave, right? from crest, from peak to peak, this here is a wavelength. Right, now you've got from there to the stationary point is the amplitude. And that's it, yeah. Right. Yep, we've got that. Right, now they're going to explain why the data logger records a varying voltage. Right, and the reason it's recording, look, can you see plus, recording a plus and then a minus, and this amplitude is changing, so we need to explain that, so we write that here. Right, first of all, the voltage is induced. Why is the voltage induced? Because, what did we say? Because the magnetic field cuts the coil. Right. As the magnet changes direction, so does the voltage. So it goes from plus to minus. As it's going down, it'll be plus. As it goes up, it'll be minus. They label the magnet. Let's have a look. Yeah, north and south. So south, as it goes down, it'll give a positive voltage. As it goes from in the opposite direction, it'll go the other way. Right. And why does it give a varying? Why does the amplitude change? Since the magnet will slow down the amplitude of the induced voltage decreases. That's a decreases. There you go. That's how you can answer that. Which feature of the graph shows that the voltage is alternating? It's going plus and minus. It's changing direction, positive and negative. It's changing direction. The voltage is changing from plus to minus. So what feature? The voltage, change color, the voltage changes direction. From positive to negative and back. Okay. So that's how you know it's alternating. It's going positive, negative. So just why the voltage changes. Why the voltage changes. As shown by the graph. We've actually done that, but okay. So the direction of the magnet, changes. The amount or number of magnetic field lines being cut changes also the direction of the magnetic field lines cutting the coil changes. That's where you get a negative voltage. And as the magnet slows down, the was it magnitude? The magnitude, this, you can just put size of the voltage gets smaller. They've used the word diminishes, but same thing. So I think we explained that up here anyway. We overcooked that, but they've asked, and we threw them both in. So the strategy you could use is put everything in, nothing's wrong. Put everything in, nothing's wrong. They'll just say ignore it. Student repeats the experiment using 2 magnets, 2, 2. Compared to 1 magnet, these 2 magnets take longer, right? So this here is showing 1 magnet. We need to show 2 magnets. So we're still expecting it to alternate, but this time we're expecting bigger and slower. Is it the same size spring? Yeah, same size spring. Same size spring. So we're expecting it to be big. So what I'm going to do is we're expecting it to be bigger, right? Yeah. Is it from there to there, from there to there? It's a tough one, that. It's not as clear as it could be. Right, okay. So we're expecting frequency to be lower, but the amplitude 1, 2, 3, 1, 2, and it's going to get smaller each time. And then it's going to get a bit, yeah. So watch this. You notice that that's there, and the next one's going to be lower, and eventually, but have you noticed it's taking, so this was 1 wavelength, whilst this one here, can you see the yellow compared to the blue is taking longer? So so the amplitude is larger and the frequency is lower, and it diminishes. They've used the word diminishes. That means it gets smaller and disappears. So look, it's getting smaller here, and eventually what will happen is it'll do something like this. That's what they're saying. Oh, right. Oh, it's a bit weird. That was the last one. Okay, it's good that these questions came up because they're slightly different to the ones that the newer IGCSE questions, so we'll live with that. Right, we know all this, right? Okay, let's call it quits. Well done.